Picture the scene. August 15th, 1977. It's a typical evening at Ohio State University, where Jerry Eman, a bespectacled and tousle-haired astronomer, is monitoring what passed for a computer in those days. This refrigerator-sized machine hums and flashes with a constellation of lights as he sifts through data from a radio telescope. You have to understand this was purely routine work. Day after day of cosmic static, interference, and the occasional stray signal from a nearby microwave oven. Then, all at once, a specific line on the printout catches his eye. Amidst an ocean of unremarkable digits, the sequence 6EQUJ5 stands out. Now, you might assume this is some kind of complex code, but it was just the system for measuring signal strength. What made this sequence extraordinary was its perfection. It was so impossibly flawless that Jerry literally jolted in his seat, reached for a red pen, and scribbled a single word in the margin. Wow. And that, quite simply, is how the legendary wow signal earned its name. From a scientist so taken aback, he could only express pure astonishment. But the truly mind-bending detail is this. The signal persisted for exactly 72 seconds. This specific duration wasn't random. It perfectly matched the time required for the radio telescope to scan a single point in the sky as the Earth turned. The transmission began the instant the telescope aimed at that location and ceased the very moment it moved past. Imagine Jerry in that moment, staring at the data, his mind racing through the possibilities. Was it a secret military satellite? Some unknown form of interference? Or could it actually be the very thing they had dedicated their lives to finding? The signal originated from the direction of the constellation Sagittarius, yet it wasn't tied to any known star, appearing instead to come from the empty space between them. Its frequency was 1,420 megahertz, a profoundly significant number because that is the precise frequency at which hydrogen, the universe's most common element, naturally resonates. If an intelligent civilization wanted to broadcast a message for anyone to find, this is the universal channel they would almost certainly choose. Here's where the mystery deepens. Jerry immediately attempted to reacquire the signal, pointing the telescope back to the exact same celestial coordinates to listen again, but he was met with only silence. He tried again the next day, and the next week, and even a year later, but there was nothing. The signal had vanished as abruptly as it had appeared. For nearly half a century, scientists have debated its origin, with some theorizing it was an intense emission from a passing comet, while others suggest it could have been a reflected radio signal from Earth, though that fails to explain its origin in Sagittarius. What I find most remarkable about this story isn't the signal itself, but Jerry's reaction. He didn't yell, "Eureka," or run through the halls to alert his colleagues. He just wrote, "Wow," and carried on with his analysis. This reflects the true nature of science, which is built on patience, deep skepticism, and the rigorous verification of every piece of data. Still, just for a second, entertain the thought. What if, on that summer evening in 1977, humanity received its first call from the cosmos? What if someone out there flipped a switch for 72 seconds, sent a pulse our way, and then simply turned it off? And you should know that the wow signal is far from an isolated incident. Over the past 50 years, astronomers have detected hundreds of anomalous signals from deep space that don't conform to any known natural phenomena. These are transmissions that last just long enough to register, broadcast on frequencies a thinking civilization might logically use. Yet every single time scientists try to zero in on their source, they disappear, as if we're in a cosmic game of hide and seek with someone who playfully reveals themselves and then vanishes the moment we look their way.
Of course, the more rational explanation might be the correct one. Perhaps these signals are indeed generated by comets, pulsars, or other natural cosmic events. It's possible our profound desire to hear a voice from the void leads us to perceive messages where none exist. But of this I am certain. When Jerry Ehman drew that red circle around 6EQUJ5, he did more than just document a strange anomaly. He opened a door to one of the most compelling mysteries of our age, a puzzle that continues to keep scientists awake at night, and one that could fundamentally alter our understanding of our place in the universe. Now, let's discuss the sheer scale of the haystack where we're searching for this cosmic needle. If you think finding extraterrestrial life sounds hard, you likely haven't grasped the true scope of the challenge. Prepare yourself. First, try to comprehend the number 400 billion. That is the estimated count of stars, not planets, not asteroids, but suns within our own Milky Way galaxy. And any one of them could host a system of planets. But that is just our immediate neighborhood. Our galaxy is merely one of an estimated 2 trillion galaxies in the observable universe. It is a number so immense that it defies human intuition. Let me offer an analogy. If you imagine every star in the Milky Way as a single grain of sand, our entire galaxy would fill a large bucket. To represent all the galaxies in the universe, you would need enough of those buckets to create a continuous beach stretching from Moscow all the way to Vladivostok. Faced with that scale, your brain simply shuts down, admitting the concept is too vast to process. And it is within this incomprehensible expanse that our search continues. Imagine detecting a radio transmission, a flicker of light, or an anomaly in the spectrum of a remote star. This search is comparable to finding one particular snowflake within a blizzard that has swirled for 13.8 billion years. Yet, the most perplexing part is that we don't truly know what we should be looking for. Perhaps extraterrestrial intelligence communicates not with radio waves, but through a medium we haven't even conceived of, such as quantum communication, gravitational waves, or a form of physics yet to be discovered. This is the point where the astronomer Frank Drake enters the story. A tall, slender man with a visionary gaze, driven by an unquenchable thirst to solve the ultimate mystery of our solitude. Back in 1960, while contemplating how to systematically address this question from his office, he sought a way to estimate the likelihood of other civilizations in the cosmos. In a moment of clarity, he jotted down a simple yet profound formula on a piece of paper, an equation now familiar to every astronomer on the planet. So, what exactly is this formula? At first glance, it appears straightforward, but a closer look reveals that it contains the complete scope of the search for extraterrestrial intelligence. The Drake equation proposes that the number of detectable civilizations in our galaxy is a product of several key variables: the annual rate of star formation, the fraction of stars with planets, the number of planets per star, the fraction of planets with life, the fraction of life with intelligence, and the fraction of intelligent life with technology formation, the proportion of those stars that possess planets, and the percentage of those planets that can support life. It continues by considering the fraction of those habitable worlds where life actually arises, the portion of that life which develops intelligence, and, crucially, the average lifespan of a technological society. The framework seems perfectly rational, but it presents a major challenge. We lack a definitive value for any of these factors, not a single one. It's akin to attempting to solve a mathematical problem where every variable is a mystery. For instance, consider the variable for how frequently life begins on suitable planets. Here on Earth, life appeared in a relatively short span, just a few 100 million years post-formation. Does this suggest that life is a common occurrence? Or was our planet an extraordinary stroke of cosmic luck? The emergence of intelligent life on our world is an even starker example, having occurred just once in 4.5 billion years. Think about it. Had the dinosaurs not been wiped out 65 million years ago, creatures like us might never have had the chance to evolve. However, the most chilling component of the Drake equation is its final term, the longevity of a technological society. We could discover a world that once hosted life, intelligence, and advanced technology. But if their civilization collapsed a million years ago, we would never know. This raises the terrifying possibility that advanced species are prone to self-annihilation, perhaps through nuclear conflict, catastrophic climate change, or runaway artificial intelligence. The emergence of intelligent life on our world is an even starker example, having occurred just once in 4.5 billion years. Think about it. Had the dinosaurs not been wiped out 65 million years ago, creatures like us might never have had the chance to evolve. However, the most chilling component of the Drake equation is its final term, the longevity of a technological society. We could discover a world that once hosted life, intelligence, and advanced technology. But if their civilization collapsed a million years ago, we would never know. This raises the terrifying possibility that advanced species are prone to self-annihilation, perhaps through nuclear conflict, catastrophic climate change, or runaway artificial intelligence. The emergence of intelligent life on our world is an even starker example, having occurred just once in 4.5 billion years. Think about it. Had the dinosaurs not been wiped out 65 million years ago, creatures like us might never have had the chance to evolve. However, the most chilling component of the Drake equation is its final term, the longevity of a technological society. We could discover a world that once hosted life, intelligence, and advanced technology. But if their civilization collapsed a million years ago, we would never know. This raises the terrifying possibility that advanced species are prone to self-annihilation, perhaps through nuclear conflict, catastrophic climate change, or runaway artificial intelligence. When Frank Drake first ran the numbers for his equation, his estimate for the number of civilizations in our galaxy fell somewhere between 1 and 1 million, an incredibly wide margin. This is comparable to a weather forecast predicting temperatures between -50 and +50 degrees. What's fascinating, though, is that in the more than 60 years since, our understanding of the cosmos has expanded dramatically. We have identified thousands of exoplanets, learned that planets are a standard feature of most star systems, detected water on Mars and subterranean oceans on moons of Jupiter and Saturn, and found that terrestrial life can thrive in the harshest environments imaginable. All of this new evidence suggests that the universe is rich with potential habitats for life. If life is not an aberration, our galaxy should be home to millions, if not billions, of life-bearing worlds. This leads to the profound question: where is everybody? We see no evidence of their existence. No radio transmissions filling the void, no colossal astroengineering projects, and no signs of visitation. Could it be that we truly are unique? Or are we searching for the wrong signals in the wrong locations? It's even possible they are already among us, and we are simply too undeveloped to perceive them, much like ants unaware of a broadcast tower overhead. This enigma, a vast, habitable universe that appears eerily empty, stands as one of the most captivating questions in all of science. You should know that this inquiry is far older than the 20th century. Our ancestors also contemplated the existence of life on other worlds, and for some, these reflections came at a terrible price. Journey back with me to the year 1592. To Renaissance Italy. Picture a monk named Giordano Bruno, clad in a brown habit, standing in a Roman piazza. He is surrounded by a pyre of firewood, the executioner's torch already in hand, awaiting his death for professing a single, simple concept. The idea that cost him his life was his conviction that the universe was boundless and filled with innumerable worlds populated by sentient creatures. While this may sound like a harmless philosophical speculation to you, it was considered profound heresy by the 16th century church. The logic was clear. If other inhabited worlds exist, then Earth cannot be the center of the cosmos. If our world isn't central, then humanity is not the pinnacle of creation, a realization that threatens to dismantle the entire established religious framework. So, as Bruno stood there in that square, the inquisitors offered him a final chance. Recant your beliefs, and your life will be spared. His response, which I find incredibly moving, was directed at his judges. Perhaps your fear in passing this sentence upon me is greater than mine in receiving it. On the 17th of February, in the year 1600, Giordano Bruno was executed by fire for holding the belief that we are not the only intelligent beings in the universe. It's astounding to consider that a man was killed for an idea that we now find entirely plausible. But the most remarkable part of his story is that Bruno was not a scientist as we understand the term today. He possessed no telescope and had no empirical proof to support his claims. He operated on the pure intuition that the cosmos was simply too immense for humanity to be its sole inhabitants. Now, try to place yourself in the minds of people from that era, as they first learned that Earth was not the center of everything. For them, the experience was akin to us discovering today that our known universe is nothing more than a soap bubble in the bathtub of some cosmic entity. It was a total revolution of consciousness. A few decades after Bruno's execution, Galileo Galilei arrived with his telescope. He was the first person in all of human history to aim a magnifying instrument toward the heavens, revealing mountains on the moons of Jupiter, the rings of Saturn, and a Milky Way composed of millions of individual stars. Can you even begin to grasp that feeling? Galileo peered through his simple telescope, noticed 4 small dots near Jupiter, and after observing them for several nights, came to a stunning realization. They were moons, orbiting Jupiter, just as our moon orbits the Earth. This meant that our planet was not unique, and that other worlds existed with their own satellites. From there, it was a short leap to wonder why life shouldn't exist on them as well. The Church, however, compelled Galileo to renounce his ideas. Being more cunning than Bruno, he formally recanted, but legend holds that he defiantly muttered, "And yet it moves." Just picture it. An old man, facing the threat of death, still unable to resist a final, whispered truth. Following him were figures like Copernicus, Kepler, and Newton. Humanity gradually began to accept that the universe was not a small, cozy dwelling with Earth at its heart. Instead, it was revealed to be a vast, cold, and indifferent space in which our world is merely an insignificant speck of dust. The more we uncovered about the cosmos, the more credible the notion of life beyond Earth became. With such a staggering number of stars and planets, why would life be a phenomenon unique to us? As early as the 15th century, philosophers were engaged in serious debate about life on other planets. Immanuel Kant theorized about the rational beings who might inhabit the moon and other worlds,
while Voltaire ridiculed those who declared humans the pinnacle of creation within an infinite universe. Then, the 19th century introduced something even more captivating. Astronomers studying Mars observed what they believed were canals, straight lines that crisscrossed the planet's surface. The Italian astronomer Giovanni Schiaparelli named them canali, which in his language simply means channels. However, when this term was translated into English, it became canals, suggesting they were artificial creations, and this ignited a firestorm of speculation. The American astronomer Percival Lowell was so convinced that he constructed an entire observatory dedicated to studying Mars, declaring that the canals were engineered structures built by intelligent Martians to channel water from the poles to the equator. Lowell authored several books about this Martian civilization, depicting its inhabitants as advanced engineers desperately trying to save their dying planet with a global irrigation network. The public was absolutely captivated. It seemed that tangible proof of extraterrestrial life had finally been discovered. But it was later revealed that the canals on Mars were nothing more than an optical illusion. The human eye has a tendency to connect unrelated dots into lines, especially when viewing an object at the very limit of its resolution. There are no canals on Mars, only craters, mountains, and valleys, with no signs of Martian engineers. Just imagine how Lowell must have felt, realizing his Martians existed only in his mind. Yet his life's work was far from a waste. It was thanks to his efforts that people, for the first time, began to think seriously about the scientific methods for finding life on other planets. Another fascinating event also occurred in the 19th century, when the German mathematician Carl Friedrich Gauss proposed the first ever method for communicating with extraterrestrial civilizations. His plan was to clear a gigantic right-angled triangle in the forests of Siberia and plant it with wheat, creating the largest geometric shape on Earth, visible from the Moon and other planets. The logic was that any intelligent species would recognize the Pythagorean theorem and understand that such a perfect triangle was the work of conscious beings. Fortunately, the project was never undertaken, as the environmental destruction would have been immense. In a similar vein, the French inventor Charles Cros proposed building a colossal mirror to focus sunlight and burn messages onto the surface of Mars, another rather extreme take on interplanetary communication. The true paradigm shift arrived at the very end of the 19th century with the human invention of radio. Suddenly, we possessed a technology that could transmit signals across vast cosmic distances. Nikola Tesla was among the first to propose that radio waves could serve as a means of contacting other planets. In 1901, Tesla constructed a powerful radio station in Colorado Springs and began his experiments, later claiming he had received bizarre signals from space, though they were almost certainly just radio interference from lightning storms. Still, the concept itself was revolutionary. Later, in 1924, when Mars made its closest approach to Earth, the United States military actually mandated a period of national radio silence. They requested all stations to cease broadcasting for 5 minutes every hour to listen for any potential signals from the red planet. Naturally, they detected nothing, but the mere fact that the attempt was made illustrates how seriously this idea was being considered. In the span of roughly 400 years, we had progressed from the execution of Giordano Bruno to the first attempts at radio contact with Mars. This brings us to the middle of the 20th century, a period when the search for extraterrestrial life graduated from philosophical speculation to a genuine science. The year is 1960. The Cold War is at its zenith, the Soviet Union is launching satellites, and America is gearing up for a lunar mission. Amidst this tense atmosphere of the space race, a 30-year-old astrophysicist named Frank Drake made a decision that would fundamentally change the entire history of this search.
Drake was working at the National Radio Astronomy Observatory in Green Bank, West Virginia. This facility was situated in a remote, mountainous region, a location intentionally chosen to shield it from the radio interference generated by large cities. It was the ideal quiet spot for listening intently to the whispers of the universe. He is standing beside a 25-meter radio telescope when a radical thought occurs to him. Instead of using it to study natural phenomena like pulsars or quasars, why not aim it toward the stars to listen for artificial transmissions from space? For its time, the proposition sounds completely absurd. Yet Drake is young, driven, and has access to cutting-edge technology, so he manages to persuade his superiors to grant him 150 hours of telescope time, a brief window to confront a question that has captivated humanity for millennia. He dubs the endeavor Project Ozma, a nod to the queen of a faraway, fantastical land from the Wizard of Oz. For his targets, Drake chooses two specific stars, Tau Ceti and Epsilon Eridani, selected because they resemble our own sun and are situated relatively nearby, at a distance of 11 light-years. Of course, describing anything in the cosmos as relatively close is like suggesting a journey to the next galaxy is just a short stroll. On April 8, 1960, at 6 a.m., Drake and his team direct the telescope toward Tau Ceti, tuning their receiver to the specific frequency of 1,420 megahertz, which corresponds to the natural emission of hydrogen. As they don their headphones and begin to listen, they are met with the expected cosmic noise, static, and random radio bursts. Hour after hour ticks by with nothing out of the ordinary, until suddenly, a distinct, rhythmic pulse emerges through the hiss. Tap, 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 tap. Drake's heart pounds with excitement. Could this truly be it? A successful detection on their very first attempt? He urgently summons his colleagues, and everyone gathers at the telescope as the clear, steady, and unmistakably artificial signal persists. The initial euphoria, however, soon gives way to disappointment when they discover the transmission isn't originating from deep space at all, but from a clandestine military radar installation nearby that was flooding the entire frequency band with its test signals. Although the first day of Project Ozma concluded in a resounding failure, Drake's resolve remained unshaken. Day after day, week after week, and month after month, he and his team continued their vigil, listening intently to the cosmos. They alternated their focus between Tau Ceti and Epsilon Eridani, experimented with various frequencies, and meticulously analyzed every peculiar signal they encountered. And you know what they ultimately found? Nothing. Absolutely nothing at all. 150 hours of dedicated observation yielded a null result. But here is the crucial point. Drake was far from discouraged. He recognized that 150 hours was merely a fleeting moment in the grand cosmic timescale, and even if civilizations existed near those stars, they might not be transmitting constantly, or could be using entirely different methods. The true accomplishment of Project Ozma was demonstrating that the search for extraterrestrial intelligence, or SETI, was not science fiction, but a tangible scientific problem that could be addressed with contemporary technology. Drake successfully showed that radio telescopes possessed the capability to detect signals from a civilization like our own across distances of hundreds of light-years. Moreover, Project Ozma captured the imagination of other scientists, and suddenly, Drake was no longer alone in dreaming about discovering intelligent life elsewhere. Esteemed physicists, biologists, and mathematicians began to seriously debate questions that had once been confined to the pages of speculative novels. In 1961, just 1 year after Project Ozma concluded, Drake organized the very first conference dedicated to the search for extraterrestrial intelligence at the Green Bank Observatory. Although only 11 scientists attended, the guest list was impressive, featuring names like Carl Sagan, Melvin Calvin, and John Lilly. It was at this gathering that Drake first introduced his now famous equation, and as he wrote it on the board, the room understood they were witnessing a monumental step forward, the first attempt to frame the question of life in the universe as a mathematical challenge. What is particularly fascinating is the profound optimism shared by the conference attendees, who speculated that our galaxy could host as many as 1 million advanced civilizations. Carl Sagan went even further, proposing that we would almost certainly receive a signal from an alien civilization within the next 10 to 20 years. And yet, more than 60 years have now gone by, and we are still met with silence. Were those early pioneers simply too hopeful? Or are we just not looking in the right way? Or perhaps, as a whimsical thought, the aliens simply forgot to turn their transmitter back on after a long vacation. Following the Green Bank Conference, the search for extraterrestrial intelligence matured into a respected scientific field, giving rise to new projects, more advanced telescopes, and innovative search methodologies. Yet, Project Ozma is forever etched in history as the pioneering effort to hear a voice from the void. What I find most astonishing about Drake's story isn't that his search came up empty, but that he had the sheer audacity to even try. Just picture a young scientist during the Cold War proposing to his bosses, "Let me use the nation's most expensive telescope to search for aliens," and them actually agreeing. It was an era defined by a profound belief in progress, in science, and in the conviction that any cosmic mystery could be unraveled with the right instruments and enough determination. It was a time when the prospect of meeting our interstellar neighbors felt like it was only a few years away. However, the universe, as it so often does, proved to be vastly more complicated than we had ever imagined. So much more complex. Let's travel back to the summer of 1950, in Los Alamos, New Mexico, at the secret laboratory where the atomic bomb had been conceived just 5 years prior. A group of physicists is making their way to the cafeteria for lunch, engaged in an ordinary conversation on an ordinary day. Then, without warning, one of them, a short Italian man with intense eyes, halts the discussion and poses a question that continues to trouble astronomers worldwide. His name was Enrico Fermi, one of the most brilliant physicists of the 20th century. "Where is everybody?" Fermi asked his colleagues, who were initially confused about whom he meant. He clarified, he was talking about aliens. If the universe is so ancient and immense, teeming with an astronomical number of planets, and if life is a natural outcome of cosmic evolution, then where are they all? This simple query, voiced during a lunch break, evolved into one of the most significant questions in modern science, the Fermi Paradox. Why, in a universe that should be bustling with life, do we observe no signs whatsoever of extraterrestrial civilizations? To understand this paradox, we must first consider that our own galaxy was formed 13.5 billion years ago. Our planet came into being 4.5 billion years ago, while human civilization is a very recent development, spanning only a few thousand years, and our mastery of spaceflight is a product of the 20th century. But consider for a moment if another civilization in our galaxy had a mere 1 million year head start on us. Can you truly appreciate the implications? That span of time is an instant on a cosmic scale, yet for technological progress it represents an eternity. To put this in perspective, think about the immense transformation of humanity in just the last 100 years. A century ago, we had not yet achieved flight, and there was no such thing as radio, television, computers, or the internet. Now, you can see we have satellites, space stations, and robotic rovers on Mars.
What advances might we see in another 100 years, or 1,000, or 1,000,000? A society that has been evolving for 1,000,000 years would likely command technologies far beyond our capacity to even conceive. You would expect them to have populated the entire galaxy, erected colossal megastructures around stars, and perhaps even learned to manipulate the fabric of space-time itself. This is where the problem becomes truly fascinating. As the physicist Enrico Fermi determined that a civilization traveling at just 1% of the speed of light could colonize the entire galaxy in only 10 million years. An insignificant period in cosmic time. By that logic, if advanced civilizations do exist in our galaxy, they ought to be ubiquitous. Their spacecraft should be a common sight in interstellar space. Their communications should saturate the radio spectrum, and their massive engineering projects should be observable through our telescopes. Yet, all we perceive is a profound emptiness. Our radio telescopes detect only silence, and the sky reveals no evidence whatsoever of cosmic-scale engineering, leaving the impression that we are utterly alone in this vast galaxy. Imagine the impact of that realization on our collective psyche. We have always held a certain belief in our own specialness, even as we hoped for the existence of other intelligent beings in the universe. It seems we are faced with two possibilities. Either we are truly unique, or our fundamental understanding of life and civilization is deeply flawed. Scientists have proposed dozens of potential solutions to this puzzle, now known as the Fermi Paradox. Some theories speculate that interstellar travel is simply impossible, while others suggest that all civilizations inevitably self-destruct before they can expand across the stars. It's also possible that they exist but are intentionally hiding from us. Or perhaps we live in a kind of cosmic preserve where advanced beings deliberately avoid interfering with our natural development. One of the most unsettling explanations is the Great Filter theory, which proposes that there is some incredibly difficult stage on the path from simple life to an interstellar society that nearly all life fails to overcome. The critical question then becomes, where is this filter located in the timeline of life? Is the insurmountable hurdle the transition from non-living matter to life, the evolution from simple to complex cells, the leap from animal to intelligent being, or the development of a technological society? The most terrifying thought is that the filter may still lie ahead of us, an unavoidable problem like nuclear war, ecological collapse, or a machine uprising that every civilization eventually faces and fails to solve. There are, however, more optimistic scenarios. Perhaps advanced civilizations simply lose interest in cosmic expansion, having discovered more compelling paths for their development, such as creating immersive virtual worlds, altering their own consciousness, or exploring quantum dimensions. Another possibility is that they are already here, but we are incapable of perceiving them, much like an ant is unaware of a cell phone tower. A civilization with millions of years of advancement might operate on physical laws we haven't even begun to grasp, existing in other dimensions, within dark matter, or in the quantum foam of space-time. But what if every one of these assumptions is wrong from the outset? Perhaps life is so exceptionally rare that we truly are the only intelligent species in our galaxy, or even in the entire observable universe. The rare Earth hypothesis proposes that the specific conditions required for complex life to arise are so numerous and improbable that Earth might be a unique case. You require a particular type of star, a planet of a precise size at an exact distance, the right atmosphere, a protective magnetic field, a large moon for orbital stability, and a gas giant to deflect asteroids. And those are just the physical necessities. Biologically, the evolutionary leap from simple to complex cells on our planet happened only once in 1.5 billion years. The emergence of multicellularity occurred just once. The development of intelligence also happened only a single time.
It's mathematically possible that out of trillions of planets, ours is the only one to have ever produced intelligent life. The most curious part is that the more we learn about the cosmos, the more baffling the Fermi paradox becomes. We are discovering an ever-increasing number of exoplanets, including those that appear Earth-like, and we are finding water and organic compounds scattered throughout the universe. All of these discoveries indicate that life should be common, which only deepens the central mystery. Where is everybody? Why are the radio telescopes silent? And why does the sky appear so empty? The answer to this question could fundamentally reshape our understanding of life, intelligence, and our own place in the cosmos. We could be on the verge of the greatest discovery in human history, or we may be fated to an eternity of solitude in the infinite void. Yet, the search for an answer has already profoundly changed us, forcing us to view our planet, our existence, and ourselves from a new perspective. Perhaps the greatest value for humanity lies not in finding the answer, but in the journey of the search itself. This is the very puzzle that an Italian physicist posed during a lunch break 70 years ago, and we are still grappling with his simple question. But in 1995, something occurred at the Haute-Provence Observatory in France that would completely transform our view on the search for life, an event so radical that the scientific community has yet to fully recover from the shock. Imagine the scene. It is October of 1995. Two astronomers, Michel Mayor and Didier Queloz, are poring over data streaming from their observations of a star named 51 Pegasi. This is an unremarkable star in many ways, a little smaller and cooler than our Sun, located about 50 light-years from us. Yet, something about it is deeply strange. The star exhibits a subtle wobble, a rhythmic shift of just a few meters per second, moving first toward us, then away, with a precise 4-day cycle. Mayor and Queloz look at each other, knowing there can be only one explanation for such a regular gravitational tug. A massive object is orbiting the star, pulling it back and forth like a cosmic pendulum. That object had to be a planet. However, when the scientific team calculated the characteristics of this newfound planet, the results were beyond astonishing. This world possesses a mass comparable to Jupiter's, yet it whips around its star in a mere 4 days, a journey our own Jupiter takes 12 years to complete. This planet is 200 times faster, orbiting 8 times closer to its star than Mercury does to the Sun. On its surface, the temperature soars above 1,000 degrees Celsius, its atmosphere a searing concoction of metallic vapors, and its winds rage at 1,000 kilometers per hour. You are picturing a gas giant so near its star that its atmosphere is literally boiling away into space. A furnace world that, by all our existing theories, simply should not be possible. Until 1995, you see, we held the firm belief that all planetary systems mirrored our own, small, rocky worlds huddled close to their star, while immense gas giants remained in the cold, distant outer regions. This arrangement seems perfectly logical, as the intense heat near a star would cause any gas giant to evaporate. Yet 51 Pegasi b, as the planet was designated, completely shattered this framework. Scientists had to devise a new explanation, suggesting the planet must have formed far from its star in a colder region and subsequently migrated inward, its orbit spiraling closer due to gravitational nudges from other planets or interactions within the primordial dust disk. What's truly incredible is that once Mayor and Queloz published their findings, astronomers across the globe began hunting for similar worlds, and they found them everywhere. These so-called hot Jupiters turned out to be common, appearing around nearly 1 in every 10 stars. This discovery opened the floodgates to even more bizarre findings. Planets that orbit 2 stars simultaneously. Planets that travel backward against their star's rotation. and worlds with orbits so elongated they alternate between the freezing void of deep space and the infernal blaze of their sun. The reality of the cosmos proved to be 1,000 times more inventive than any work of fiction. If you think about science fiction, its planets were always so conventional, worlds of ice, desert, or forest. The universe, however, offers far stranger possibilities. There are planets composed of pure carbon, where it likely rains diamonds from the sky. We have found worlds with atmospheres of vaporized rock, and others where winds screaming at 7,000 kilometers per hour drive horizontal rain made of molten glass. Imagine planets so close to their stars that their surfaces are entirely molten, featuring rivers, oceans, and even clouds of lava, all on a scale larger than Earth. Then you have the rogue planets, which are not tethered to any star at all. These cosmic wanderers drift through the galaxy in absolute darkness and cold, having been violently ejected from their home systems millions of years ago. Picture such a world, where surface temperatures hover around -200 degrees Celsius, locked in an eternal night with no sunrises or seasons. The only change is the slow, silent procession of distant stars as the planet journeys through the galactic void. At the other extreme are planets that orbit pulsars, the super-dense, rapidly spinning remnants of massive stars. The radiation bombarding these worlds is so intense that it would tear any organic molecule apart in an instant. Yet somehow, these planets endure. The true revolution in our understanding began in 2009 with the launch of the Kepler Space Telescope, a mission created specifically to find planets beyond our solar system. Over its 9-year mission, Kepler's discoveries surpassed every expectation, identifying more than 4,000 planets of all kinds, large and small, rocky and gaseous, hot and cold. It revealed that planets are not a rarity, but a common feature, existing around nearly every star in our galaxy. Crucially, Kepler found planets within what is known as the Goldilocks zone, the orbital region where conditions are just right for liquid water to exist. For instance, there is Kepler 442b, a planet slightly larger than our own, that receives a similar amount of energy from its star as Earth does from the Sun, making it a candidate for oceans, continents, and perhaps even life. Then you have Kepler 452b, a world so strikingly similar to ours in size, temperature, and illumination that it has been nicknamed Earth's cousin. And in 2016, an even more incredible discovery was made. A planet orbiting Proxima Centauri, the very closest star to us, just 4.25 light-years away. This planet, Proxima Centauri b, is Earth-sized, resides in the habitable zone, and could very well be our nearest living neighbor. As we continue to discover more of these distant worlds, the most astounding revelation is that our own solar system is the anomaly, not the standard. Most of the planetary systems we have observed look nothing like ours. In many of them, planets are packed much more closely together. Their orbits are frequently elliptical instead of nearly circular, and there is a prevalence of planets with sizes between that of Earth and Neptune, a category of world that for some reason our own system completely lacks. It seems the more we learn about the galaxy, the more we realize just how unique our home really is. It's a common misconception that gas giants are always far from their stars. In reality, they are often discovered extremely close. This realization revealed that our search for life has been based on the flawed premise that other solar systems must resemble our own, which they frequently do not. This doesn't eliminate the possibility of extraterrestrial life, but it does suggest that it could be far stranger than anything we have ever conceived. I want you to picture life on a world where a full year passes in only 4 of our Earth days, and where the temperature fluctuates wildly between 1,000 degrees and -200,
Or consider a planet that is tidally locked, with one hemisphere scorched in unending daylight, while the other is frozen in perpetual darkness. These are the kinds of alien environments that we now know exist. Perhaps life doesn't even require a planet to begin with. It's conceivable that it could flourish high in the atmospheres of gas giants, drift within the icy particles of Saturn's rings, or even coalesce in the vast clouds of interstellar gas. The discovery of exoplanets has fundamentally shown us that the cosmos is infinitely more varied and peculiar than we ever believed, which implies that life itself could share that same bizarre diversity. If we are serious about finding it, you can see we must radically broaden our definition of what life is and where it might be found. So, let's consider what life truly requires. For a very long time, the scientific consensus was that a perfect life-bearing planet needed a specific set of conditions. It had to be in a temperate zone, possess liquid water, and be shielded by a thick atmosphere from cosmic rays and a magnetic field from solar winds. This thinking gave rise to the idea of the Goldilocks zone, that narrow orbital band around a star where conditions are supposedly just right. But then, a series of discoveries completely shattered our preconceived notions about biology. Scientists started investigating Earth's most hostile environments, places where, by all logic, nothing should be able to survive. What they discovered there was not an absence of life, but an abundance of it. They found billions of bacteria thriving in conditions that would instantly annihilate nearly any other organism we know. Imagine bacteria living deep underground, in caves, untouched by sunlight, where temperatures climb to 100 degrees Celsius, and the water is acidic enough to dissolve metal. Yet they thrive by consuming sulfur, iron, and even radiation. Consider the vents of undersea volcanoes, where the temperature hits 300 degrees Celsius, and the crushing pressure, hundreds of times greater than at the surface, keeps water from boiling. In this seemingly impossible place, life flourishes. In these deep-sea vents, entire ecosystems exist that are not dependent on sunlight and photosynthesis, but on a process called chemosynthesis. Think about these organisms for a moment. They inhabit an environment that would vaporize a human being in a fraction of a second. Yet to them, it is home. They reproduce. They evolve. They fight microscopic battles. And for all we know, they might even engage in some form of microscopic recreation. Some bacteria make their homes in radioactive waste, feeding on the very energy that is lethal to almost all other forms of life. They don't simply endure the radiation. They harness it as a power source in the same way plants use sunlight. One famous example is a microbe named Deinococcus radiodurans, whose name loosely means terrifying berry that withstands radiation. This organism can survive a radiation dose 1,000 times more powerful than what would be fatal to you, meaning it could witness a nearby hydrogen bomb detonation, shrug it off, and continue with its day. There are other microbes that swim happily in concentrated sulfuric acid, a substance corrosive enough to eat through iron. For these creatures, an alkaline environment, which we would consider normal, is a deadly poison. All of this incredible resilience exists right here, on our own world. Now, just try to imagine the forms of life that might have evolved on other planets. If life on Earth can adapt to withstand pure acid and intense radiation, what might be thriving in the upper clouds of Venus, the liquid methane lakes of Titan, or the hidden subsurface oceans of Europa? Venus presents a truly hellish landscape, with surface temperatures of 470 degrees Celsius, atmospheric pressure 90 times that of Earth, and clouds laced with sulfuric acid. It appears to be a completely sterile world.
And yet, scientists recently detected phosphine in the Venusian atmosphere, a gas that, on our planet, is produced exclusively by living organisms. This finding has led to a fascinating hypothesis. Perhaps 50 to 60 kilometers above the scorching surface, where the temperature is a manageable 50 degrees and the pressure is comparable to Earth's, microscopic life is floating in the clouds. It's possible they sustain themselves on atmospheric chemical compounds and reproduce within droplets of sulfuric acid. Then you have Titan, the largest moon of Saturn, which features entire lakes and rivers not of water, but of liquid methane, at a temperature of minus 180 degrees Celsius. While it lacks water and oxygen, it possesses complex organic molecules and an internal energy source from radioactive decay. It is entirely plausible that methane-based organisms swim in Titan's rivers, breathing hydrogen and metabolizing hydrocarbons in an environment that would freeze our cells solid in an instant. Europa, one of Jupiter's moons, conceals a vast ocean beneath its thick crust of ice, an ocean that holds more water than all of Earth's seas combined. This immense body of water has existed for billions of years, kept liquid by the powerful tidal forces exerted by Jupiter. In this world of eternal darkness, without sunlight, day or night, hydrothermal vents similar to those on Earth's ocean floor could be fueling bustling ecosystems. Consider for a moment what it would mean if life has been evolving there for 4 billion years, completely cut off from the rest of the universe. What could it possibly look like? What form might its intelligence take? Would it bear any resemblance at all to life as we know it here on Earth? We can also look to Enceladus, a tiny moon of Saturn, only 500 kilometers in diameter. Beneath its frozen shell, it also harbors a liquid ocean that erupts into space through giant cracks in the ice. These plumes have been found to contain organic compounds, salts, and hydrogen, every essential ingredient for life. This suggests that even very small worlds can be habitable, and that size may not be a barrier, as long as the necessary energy and chemical components are present. What if we push this idea even further? What if life can exist entirely without planets, finding a home in interstellar nebulae, the churning atmospheres of gas giants, or the rings of Saturn? Is it possible that life could learn to draw energy from magnetic fields, gravitational waves, or perhaps even the mysterious force of dark matter? The more we study Earth's extremophiles, the clearer it becomes that life is not some delicate flower requiring perfect garden-like conditions to grow. On the contrary, life is an incredibly tenacious and adaptable force, capable of conforming to almost any environment imaginable. All it seems to truly need is a source of energy and an abundance of time. The universe is brimming with both the necessary ingredients and the opportunities for life to emerge. You have stars, radiation, chemical reactions, tidal forces, and magnetic fields, representing countless energy sources, plus a timeline of 14 billion years for any conceivable experiment to run its course. This makes you wonder if the right question is not whether life exists elsewhere, but rather, where in the cosmos it doesn't. Perhaps life is a standard, widespread phenomenon that arises under any minimally suitable conditions, which then begs the question, where are all the other civilizations? And why have we yet to intercept any of their signals? Before we tackle that puzzle, let's explore what a message from deep space actually sounds like. The cosmos is far from a silent vacuum. It's actually filled with a symphony of sounds, provided you know which frequencies to tune into and how to decipher what you're hearing. Picture a radio astronomer in the middle of the 20th century, donning headphones and activating a receiver. As they scan a specific frequency, they're met with a barrage of noise, static,
electromagnetic bursts, and even interference from everyday devices like microwave ovens and car engines. Yet, piercing through this cacophony, something peculiar occasionally emerges. A signal with a regularity so profound that it seems impossible for it to be natural. Imagine hearing a persistent tap, 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 pulsing with the unerring precision of an atomic clock. In that moment, the astronomer would surely bolt upright, possessed by the thought that this could finally be the moment of contact. This exact scenario unfolded in 1967 when Jocelyn Bell, then a graduate student in England, made the groundbreaking discovery of the first pulsar. While studying the scintillation of distant galaxies, Bell detected an unusual signal, a series of radio bursts arriving every 1.3 seconds with clockwork regularity. The pattern was so consistent, in fact, her initial hypothesis was that it had to be of alien origin. The source was even provisionally labeled LGM-1, which stood for Little Green Men 1. Just think about that. Esteemed scientists at Cambridge were officially cataloging a celestial source with the name Little Green Men. The reality, however, proved to be something even more extraordinary. A neutron star, no larger than a city, but containing more mass than our own sun. This stellar remnant rotates at an astonishing speed, sweeping a focused beam of radio waves through space like a cosmic lighthouse. Each time this beam sweeps past Earth, our instruments register a distinct pulse of energy. The fascinating part is that a pulsar's signal genuinely mimics the characteristics of an artificial one, being almost too precise and orderly to seem natural. Had we not unraveled its true nature, we might still be considering it a message from another world. This entire experience brings us to the core challenge. How can we possibly differentiate a signal of natural origin from one that is genuinely artificial? What markers would allow us to confidently say we've received a communication from intelligent beings, rather than having just stumbled upon another exotic cosmic phenomenon? To address this, scientists have established several key criteria for identifying a potential extraterrestrial transmission. First, the signal must be narrowband, meaning it's concentrated within a very tight frequency range, unlike the broadband noise of most natural sources. Think of the difference between a single note from a flute and the roar of a waterfall. Second, the signal ought to show a frequency drift consistent with the Doppler effect. If the source is a planet orbiting its star, the signal's frequency would predictably rise as it moves toward us and fall as it recedes, mirroring the change in pitch of a passing ambulance siren. Third, the signal's origin must be a fixed point against the backdrop of the stars, moving with the celestial sphere rather than remaining stationary from an Earth-based perspective. Finally, the signal needs to be modulated, as a simple, unvarying carrier wave contains no information. An intelligent species would almost certainly embed data within the signal, such as mathematical constants, prime numbers, or even visual information like star maps. Unfortunately, a major hurdle remains. We have no idea which frequencies to monitor. The radio spectrum is immense, spanning from just a few hertz to several terahertz, and an alien civilization might be using any part of it. Or perhaps they don't use radio waves at all. This is why astronomers have often concentrated their efforts on what's known as the water hole, a quiet frequency band situated between the natural emission lines of hydrogen and hydroxyl. The rationale is straightforward. Any civilization capable of radio astronomy would recognize these fundamental frequencies, and these two molecules combine to form water, the very basis of life as we know it. Still, this strategy could be profoundly short-sighted. What if other civilizations use entirely different frequencies, or have abandoned radio waves for more advanced methods? In recent years, Scientists have expanded their search to include what are called technosignatures, any detectable evidence of a technologically advanced society's activities. This could involve, for instance, searching for industrial pollutants in the atmospheres of exoplanets, since an industrial civilization would likely introduce chemical compounds not found in nature. Another possibility is looking for the glow of artificial lighting from cities on the night side of a distant world, a feat that, while requiring next-generation telescopes, is theoretically within reach. We can also search for evidence of megastructures. A sufficiently advanced civilization might construct enormous objects around its star to capture energy, such as Dyson spheres, Alderson disks, or vast swarms of solar collectors. Any such structure would periodically obstruct the star's light, producing very distinctive patterns in its brightness. In fact, precisely such erratic fluctuations have been recorded from the star KIC 8462852 in the Cygnus constellation. Its brightness dips unpredictably, sometimes by as much as 20% over a few days, a phenomenon for which no known natural process offers a clear explanation. Could this be our first glimpse of a colossal alien engineering project, perhaps a Dyson sphere in the middle of its construction? Or is it more likely just a massive, irregular cloud of comets passing in front of the star? It's also entirely possible that highly advanced civilizations have transcended radio communication altogether. They might be utilizing untraceable methods like quantum communication, harnessing gravitational waves, or employing some other form of physics so exotic that we are not yet even capable of imagining it. When I reflect on the search for these signals, what I find most astonishing is that we are fundamentally looking for something we cannot comprehend. We are straining our ears to hear a message that we are unable to define, sent from beings we can scarcely imagine. It's a search for a ghost in the machine of the universe, and we don't even know what the ghost sounds like. We are hoping to encounter something that defies all our expectations, yet the search itself is a remarkable endeavor. With the most sensitive instruments ever created, we are aiming at the cosmos and essentially announcing, if there is anyone out there, we are paying attention. It is the equivalent of standing on the edge of a boundless ocean and calling out into the void, anticipating some kind of answer. But what if a reply has already been sent? It's conceivable that space is teeming with signals we lack the ability to recognize. It's even possible that as you listen to my voice right now, radio waves from a faraway civilization are passing harmlessly through your body. Contemplate this. For 50 years, extraterrestrials could have been attempting to make contact, broadcasting messages and awaiting a response, while we remain oblivious, searching in the wrong ways, much like a deaf person unaware they are being spoken to. Even so, the search has profoundly altered us, regardless of our lack of discovery. This quest has forced us to reconsider the universe, our position within it, and the very definition of intelligent life in an infinite expanse. And it's impossible to know when everything might change. A signal could arrive tomorrow, next year, or in a decade. A transmission from one of our radio telescopes with a simple message. Hello, Earth. We are here. Until that day comes, we continue to listen. We monitor the cosmos every day, every night, and every second, hoping to detect the voice of a cosmic neighbor. However, after decades filled with so many false alarms, scientists now treat every unusual signal with a great deal of caution, because the resulting letdown can be intensely disheartening. On December 24th, 2020, Christmas Eve, astronomers across the globe were getting ready for the holidays as radio telescopes continued their automated sky surveys. Abruptly, the computer systems at the Parkes Observatory in Australia registered a narrowband signal
originating from the direction of Proxima Centauri, our nearest stellar neighbor. The transmission, at a frequency of 982 megahertz, persisted for a few hours before vanishing completely. Picture the scene. Scientists return from their holiday break, comb through the collected data, and discover this transmission from the closest star system, which hosts a planet in the habitable zone. This was a signal that could redefine everything. They designated it BLC-1 for Breakthrough Listen Candidate 1, marking it as the first credible candidate for an alien signal in the program's entire history. For months, the team guarded this secret, meticulously re-examining the data and scrutinizing every last detail, all while holding the key to potentially the greatest discovery in human history. Yet, the deeper they delved into their analysis, the more questions surfaced. Why that specific frequency of 982 megahertz? What was the significance of its duration? And most critically, why did it never appear again? Subsequently, the investigation intensified as scientists aimed every telescope at their disposal toward Proxima Centauri, listening for days, weeks, and then months, only to be met with complete silence. The signal had disappeared as mysteriously as it had arrived. Eventually, someone identified a peculiar pattern. The signal was only detected when the telescope was pointed at Proxima Centauri and vanished the moment it moved away. This suggested the source was not in deep space, but was, in fact, somewhere on or near Earth. It was soon confirmed that BLC-1 was nothing more than interference from an electronic device, possibly a microwave in a nearby building, a cell phone, or even a clock synchronized by radio. For 6 months, the world's leading astronomers had been studying a signal from a kitchen appliance. No one was truly disappointed, however, because each false alarm provides an invaluable lesson in how to differentiate between artificial and natural phenomena, and between terrestrial noise and a genuine cosmic message. But the story of BLC-1 pales in comparison to the saga of the wow signal, which is where we began this discussion. For more than 40 years, astronomers have been attempting to solve the mystery of its origin. Numerous theories have been proposed. Could it have been generated by a comet? In 2017, a team of scientists put forward the idea that Comet 266P/Christensen, which was transiting that region of the sky in 1977, might have been the source. The hypothesis was that the comet's surrounding hydrogen cloud could emit radiation at 1,420 megahertz. Other researchers, however, countered that the emission's intensity would be far too weak to account for the strength of the wow signal. Another possibility considered was a reflected terrestrial signal, perhaps from a military transmitter bouncing off space debris. But that failed to explain why it originated from the Sagittarius constellation. Then there is the most tantalizing explanation, that it was a genuine, one-time broadcast from an extraterrestrial intelligence, designed to capture our attention before they fell silent, awaiting our reply. Just imagine it. Somewhere in the constellation Sagittarius, a civilization has been patiently observing for half a century, wondering, it's strange. We transmitted a signal to them in 77, but have heard nothing back. Did they not receive it? Or did they not comprehend it? Or perhaps they understood, but are too afraid to answer. It is also conceivable that they have sent numerous signals, and we have simply failed to detect them. When the WOW signal was captured, humanity possessed only a single radio telescope dedicated to listening to the universe. If that signal had repeated a day, a week, or a month later, it's highly probable that we would have missed it entirely. But the most profound letdowns often come not from distant signals, but from discoveries made right here in our own solar system. Consider Percival Lowell and his Martian canals.
He dedicated his life to observing Mars, authored books about its advanced civilization, and persuaded much of the world that intelligent beings inhabited the red planet. Then, spacecraft imagery revealed Mars for what it is: a frigid, barren desert devoid of canals, Martians, or any sign of civilization. Only craters, rocks, and dust. Another example is the Antarctic meteorite ALH 84001. In 1996, a team of scientists made the stunning announcement that this rock from Mars held traces of ancient life in the form of microscopic structures resembling fossilized bacteria. The entire world was captivated by the news, believing we had finally found proof that life had once thrived on Mars. However, subsequent scientific analysis demonstrated that these structures could have been formed through entirely non-biological means, and that particular debate is still ongoing. A more recent instance involves the discovery of phosphine in Venus's atmosphere. In 2020, a team of researchers announced the detection of this gas, which on Earth is produced only by living organisms, within the Venusian clouds, creating an immediate sensation about the possibility of life there. It was later suggested, however, that the initial measurements may have been inaccurate, as other scientific teams were unable to corroborate the findings, or detected phosphine in such minute quantities that a biological origin seems unlikely. The deepest frustration with these false alarms isn't just about being mistaken. It's that each one makes it more difficult to persuade the public that the search for extraterrestrial life is a serious scientific endeavor. People begin to think, here go the astronomers again, discovering aliens that are actually just microwave ovens. Consequently, when a genuine breakthrough finally occurs, a significant portion of the population might meet it with skepticism. But here's the crucial point. Every false start ultimately makes us better scientists. It trains us to be more cautious, more critical, more insistent on solid proof, and better able to separate genuine data from our own hopes. Furthermore, each of these disappointments reveals just how deeply we desire to find intelligent life, how prepared we are to celebrate any clue to its existence, and how much we long to hear a voice from deep space. There's a profound beauty in that, because this hope is central to our humanity. The hope that we are not solitary in this immense universe, and that somewhere else, other intelligent beings are also gazing at the stars and dreaming of making contact. Or is it possible they have already found us? It could be that in some remote galaxy, alien scientists are currently analyzing radio waves from Earth and concluding, it seems there is intelligent life on the third planet orbiting that yellow dwarf star. We should transmit a signal. And perhaps that very signal is already traversing the interstellar void toward us at the speed of light. We might detect it tomorrow, or next year, or in a decade. Until that day comes, we continue our search. We learn from our missteps, refine our techniques, construct new telescopes, and hold on to the hope that the next signal we find will not be another false alarm, but a real message from an intelligent civilization. And I'll tell you this, modern alien hunters possess technologies that astronomers of the last century could only have dreamed of, and their stories are even more incredible. Imagine the scene in Silicon Valley, California in 2015. The Russian billionaire Yuri Milner, who built his fortune on internet investments, steps onto the stage at the Royal Institution in London to announce an initiative poised to change everything. Breakthrough Listen. He pledges to invest $100 million into the most ambitious search for extraterrestrial life in human history, with the goal of monitoring 1 million stars in our galaxy and 100 nearby galaxies. $100 million. That figure is staggering. It surpasses the total amount spent on the search for extraterrestrial intelligence throughout all of prior history, and exceeds the entire budgets of some countries,
all from a single man who decided that discovering intelligent life was a greater priority than owning yachts and castles. But this endeavor is about far more than just money. It's about a technological revolution. By 2015, we had access to capabilities that Frank Drake lacked in the 1960s, including computers capable of analyzing terabytes of data in real time, and artificial intelligence that can identify patterns within billions of disparate signals. To understand the scale, picture a modern system for this search: an array of hundreds of radio telescopes, each the size of a football field, all scanning the sky across millions of frequency channels simultaneously. Every second, they produce more data than a human could review in a lifetime, which is then streamed to a processing center. In this center, thousands of processors scrutinize every single signal. Artificial intelligence works to filter out interference, flag transmissions of interest, and cross-reference them with a database of known sources. All of this happens automatically, with no human input required. If this system identifies something out of the ordinary, it immediately dispatches an alert to astronomers across the globe. They would then direct other telescopes toward the source to verify and confirm the finding. If the signal proves to be genuine, just imagine that moment. A computer in the data center generates a notification. Potential extraterrestrial signal detected. Coordinates: right ascension 1430, declination -40 degrees. Frequency 1 gigahertz. Modulation unknown. Within minutes, astronomers worldwide would receive this message, drop everything they are doing, and point their instruments at those coordinates, because it could represent the very moment they have dedicated their entire lives to achieving. Breakthrough listen, however, is not confined to radio telescopes. It also involves searching for optical signals. It's plausible that extraterrestrials might employ lasers for interstellar communication instead of radio waves. A laser pulse lasting just a nanosecond could carry an immense amount of information, and if aimed precisely at our planet, it could cause a distant star to appear momentarily brighter. Modern optical search systems can detect a laser pulse as faint as a few kilowatts from hundreds of light years away, and if a civilization were using megawatt-class lasers, we could potentially spot them from thousands of light years away. There is also the ongoing search for megastructures. You may remember the star KIC 8462852, also known as Tabby's star, in honor of the astronomer Tabitha Boyajian who studies it, whose brightness fluctuates in unpredictable ways. Today's telescopes are capable of monitoring the brightness of millions of stars concurrently, hunting for such anomalies. If a civilization were constructing a Dyson sphere, an Alderson disk, or some other massive edifice, it would undeniably impact the light from its star. Artificial intelligence can now sift through billions of observations to detect these subtle changes. More recently, astronomers have also started searching for technosignatures, the telltale traces of industrial activity that might be found in the atmospheres of exoplanets. The James Webb Space Telescope gives us the power to analyze the atmospheric makeup of planets that are dozens of light years from Earth. Should an industrial society exist out there, it would almost certainly be emitting unnatural chemical compounds into its air, such as chlorofluorocarbons, nitrogen oxides, or industrial vapors. Every one of these substances is detectable through spectroscopy, so you can just imagine discovering a world whose atmosphere is clouded with the smog of factories. A discovery that would offer the first definitive proof of a technological civilization in all of human history. It is a somewhat sobering thought that our first sign of intelligent life could be its industrial pollution, but progress often comes with unavoidable downsides. Another promising avenue of investigation is the search for artificial illumination. If cities exist on the night side of an exoplanet, their collective glow might be visible to us. While detecting this light would demand telescopes more powerful than any we currently have, it remains a genuine technical possibility.
And perhaps the most remarkable aspect of this entire endeavor is that it's not confined to professional astronomers. In fact, ordinary people from all over the world are contributing by helping to process vast amounts of data through distributed computing projects. SETI at home stands as one of the most well-known of these efforts, where millions of individuals have installed software on their computers to scan radio telescope data for alien signals during their device's idle time. This effectively creates a global, crowdsourced hunt for extraterrestrial intelligence. Just picture it. A student in Murmansk could be finishing their homework while their computer quietly scans signals from the Cygnus constellation. At the same time, an office worker in Tokyo might be streaming a film as their laptop sifts through cosmic radio noise for meaningful patterns. This is a worldwide collaborative effort happening every single second. More recently, new projects have sprung up that allow regular people to hunt for exoplanets themselves by examining stellar brightness data for the periodic dimming that signals a planet passing in front of its star. And the incredible result is that amateurs are actually discovering new worlds. A teacher in Germany, a homemaker in Australia, or a student in Brazil can now analyze data from space telescopes from their own homes and make discoveries that get published in major scientific journals. For the very first time in our history, the quest for extraterrestrial life is open to absolutely anyone. You no longer need to be a professional astronomer or own a powerful telescope. All that's required is a computer and a genuine passion for finding intelligent life elsewhere. What if it is your machine that detects the first authenticated signal from another civilization? Can you imagine being the person who single-handedly changes the course of human history? It may sound like something from science fiction, but this is now a very real possibility. However, the most stunning feature of the modern search is its sheer speed. In the past, it could take astronomers months to painstakingly analyze their data, whereas today, intriguing signals can be identified and confirmed within a matter of hours, or sometimes even minutes. This accelerated pace means that if something truly unusual occurs in the cosmos, we are poised to know about it almost immediately, allowing us to focus all available instruments on the source right away. It's entirely possible that as you are listening to me speak, an artificial intelligence in a distant data center is analyzing a signal that will fundamentally alter everything we know. The news that we are not alone in the universe could arrive in just a few hours, or perhaps tomorrow, or even next year. But with our current technology, resources, and collective motivation, it truly feels as though a profound discovery is imminent. Until that day comes, the search continues relentlessly. Every moment of every day, thousands of people and millions of computers across the planet are dedicated to the single mission of finding signs of life beyond Earth. And who knows? Today might just be the day we succeed. But I should point out that this quest isn't only about looking toward distant stars. It's conceivable that our intelligent neighbors are far closer than we imagine. Let me take you back to August 4th, 2012. Inside the Jet Propulsion Laboratory in Pasadena, California, hundreds of scientists were transfixed by large screens showing a live broadcast from Mars. They watched as a six-wheeled, car-sized robot named Curiosity descended a ramp from its landing craft, its wheels making first contact with the Martian soil. At that moment, the most sophisticated research vehicle humanity has ever built was ready to commence its mission on the Red Planet. And the fascinating thing is, it could find evidence of life tomorrow, or the day after that. It's even possible that the discovery has already been made, and the data is currently making its long journey through space back to us. This is because Mars is not the barren, lifeless desert it was once thought to be. It was once a world where oceans sloshed, rivers carved through the land, and rain nourished the soil. A world that, billions of years ago, had all the right conditions for life to begin. If you picture Mars 4 billion years ago, you would see a planet with a thick atmosphere, a warm climate, and enormous oceans covering its northern hemisphere. Volcanoes would be erupting,
forging new islands and mountains, while lightning storms synthesized complex organic compounds in the air. In this vibrant world, within some warm, shallow lagoon, it's easy to imagine the first stirrings of life taking hold. And we know that this vision of an ancient, watery Mars is not just fantasy. The Curiosity rover, along with others, has uncovered definitive proof of ancient rivers, lakes, and even seas. These robotic explorers have found clay minerals that can only form in the presence of water, and they have detected organic compounds, the very molecules that could be the lingering chemical traces of ancient organisms. Furthermore, recent discoveries have confirmed the existence of immense reserves of liquid water deep beneath the Martian surface, held in subsurface lakes that have likely been stable for millions of years. This water is extremely salty, almost a brine, but it is liquid nonetheless. Given that life on Earth thrives in our planet's saltiest lakes, there is every reason to believe it could do the same on Mars. Just think, at this very moment, as you listen to my voice, bacteria could be swimming in a subterranean Martian lake, feeding on dissolved chemicals, reproducing, and evolving. It's conceivable that Mars harbors an entire hidden ecosystem that we are completely unaware of. But what if we find something beyond mere bacteria? What if, protected from radiation in deep Martian caves, more complex, multicellular organisms have managed to evolve? We could potentially find creatures resembling fish, worms, or other forms of primitive animal life. While it might seem like a premise from science fiction, you should remember that life here on Earth endures in the most extreme environments imaginable, from boiling hot springs and icy caves to radioactive wastelands. By comparison, the conditions within Martian caves could prove to be far more accommodating. But you must understand that Mars is merely the first stop on this extraordinary journey. There are destinations in our solar system where the circumstances for life might be even more favorable than on our own world. Consider Europa, Jupiter's fourth largest moon, which from a distance resembles a giant ice ball crisscrossed with cracks and fractures. Beneath that icy crust, which is kilometers thick, there is an ocean, one that is 100 kilometers deep and contains more water than all of Earth's seas combined. This immense ocean has existed for billions of years. The warmth within this hidden sea is generated by tidal forces from Jupiter, which constantly stretch and compress Europa's core, creating heat. This process suggests the temperature there could be quite suitable for life. I want you to picture this subsurface world, a realm of eternal darkness, untouched by sunlight and without seasons. Yet, on its floor, hydrothermal vents like those on Earth could be active, supporting entire ecosystems based on chemosynthesis. It was recently discovered that Europa's ocean is likely much more than just a body of water. Data from the Galileo spacecraft indicated layers of differing density beneath the ice, hinting at the existence of currents, temperature gradients, and perhaps even underwater mountains and valleys. An entire, functioning world beneath the frozen shell. What's truly astounding, however, is that water from this ocean sometimes erupts through to the surface in geysers that shoot hundreds of kilometers high, instantly freezing and falling back down as ice particles. Imagine the possibilities. We could analyze Europa's ocean without ever having to drill through its formidable ice shield. We would simply need to fly a probe through one of these plumes to examine its composition. If there are organic compounds or even living cells present, we will surely find them. Then you have Enceladus, a tiny moon of Saturn measuring just 500 kilometers in diameter, which also possesses a subsurface ocean and expels plumes into space through cracks in its southern hemisphere. The Cassini spacecraft navigated through these plumes and detected not only water and salts, but also organic compounds and even molecular hydrogen. On Earth, this gas is a byproduct of either biological or geological processes. The sheer amount of molecular hydrogen on Enceladus leads scientists to believe there could be hydrothermal vents similar to those on our own ocean floors. And if such vents exist, they could be supporting life that has evolved for billions of years in complete isolation from the outside universe. And you also have to consider Titan, Saturn's largest moon. It stands as the only place in our solar system, aside from Earth, with stable liquid on its surface. Though this liquid is not water, but methane, forming entire rivers and lakes. The temperature there is a frigid -179 degrees Celsius, and its atmosphere, denser than Earth's, is composed of nitrogen and methane. On Titan, it rains methane and snows organic compounds, and within its hydrocarbon lakes, life based on an entirely different chemistry might exist. Try to envision creatures for whom methane serves the same purpose as water does for us. Beings that breathe hydrogen, consume hydrocarbons, and thrive at temperatures that would instantly freeze any life from Earth. It would be a form of life, but completely alien to our own. Or, perhaps life exists where we would least imagine it, like within the atmosphere of Venus. It is true that Venus's surface is an inferno of 470 degrees Celsius, with atmospheric pressure 90 times that of Earth's. However, at an altitude of 50 kilometers, the conditions are quite manageable, with a temperature around 0 degrees Celsius and pressure similar to ours. While the atmosphere consists of carbon dioxide with traces of sulfuric acid, we know there are bacteria on Earth that flourish in acidic environments. The recent detection of phosphine in Venus's atmosphere, a gas that on our planet is produced exclusively by living organisms, suggests that microbial life may indeed be drifting within its clouds, forming entire ecosystems suspended in the air. And I want you to know that this search for life in our solar system is not a futuristic fantasy. These are actual missions being planned for the coming years, including probes to drill through Europa's ice, drones to fly in Titan's atmosphere, and robots designed to dig into Martian soil. It's quite possible that the next great discovery will happen very soon, perhaps when a rover uncovers something in the soil of Mars that forces us to completely reconsider what we know about life. Or it could be that when we finally break through Europa's ice, we will be met in the dark waters of its subsurface ocean by creatures that evolved entirely independent of Earth. That would signify a second Genesis in the history of the universe. If we discover life within our own solar system, it would demonstrate that life is not a unique event, but can emerge wherever the conditions are suitable, implying that the cosmos is filled with living worlds. But what if, out there in space, we find not merely life, but entire civilizations that have been developing for millions of years, reaching technological heights we can barely comprehend? I want you to imagine a civilization that has existed for 1 million years, not 1,000, not even 10,000, but 1 million years of sustained technological advancement. What could such a society accomplish? For starters, it would have thoroughly colonized its own planetary system, constructing cities on all of its planets and moons, creating artificial worlds, and mastering the ability to control weather, alter planetary orbits, and even reposition entire stars. But that would only be the beginning. Eventually, the energy provided by a single star would no longer be sufficient for its ambitions. At that point, it would likely construct a Dyson sphere, a colossal structure designed to encircle its star and capture all of its energy. A Dyson sphere isn't the solid shell many people picture. It's a massive swarm of millions of solar collectors, each the size of a continent,
orbiting the star to absorb its radiation and convert it into usable power. Just try to picture a structure on such an immense scale. Such an object would entirely obscure the light of its star, causing the star to seemingly disappear from our view on Earth. Yet, within the infrared spectrum, it would blaze with unusual brightness, as the Dyson sphere itself would radiate immense heat. A civilization with the technology to construct a Dyson sphere could achieve even more incredible feats, such as relocating stars, engineering artificial black holes, or even manipulating the fabric of space-time itself. Back in 1964, the Soviet astrophysicist Nikolai Kardashev introduced a method for categorizing civilizations according to their energy consumption. A Type 1 civilization is one that has mastered all the energy available on its home planet. A Type 2 civilization goes further, harnessing the total energy output of its star. Finally, a Type 3 civilization would command the energy of its entire galaxy. Measured against this scale, you can see that humanity has not even achieved Type 1 status. We currently utilize only a minuscule portion of the solar energy that reaches our planet. However, if our current pace of technological advancement continues, we might well reach the Type 1 milestone within a few hundred years, which begs the question of what would follow. A Type 2 civilization is something almost beyond our comprehension. It would possess the ability to erect structures on the scale of planetary orbits, fashion artificial worlds tailored to any conceivable environment, and perhaps even prolong the lifespan of its star by managing the nuclear fusion processes in its core. And a Type 3 civilization? Its power would be godlike, capable of reshaping whole galaxies, igniting new stars, and directing the course of life on a cosmic scale, rendering distances of millions of light-years trivial. And you have to wonder, could such civilizations already be out there? It's possible that at this very moment, somewhere within our galaxy, a society is busy rearranging star clusters, constructing new planetary systems, or conducting experiments with the fundamental physics of the universe. It's even conceivable they have already taken notice of us, viewing our world as we might view an anthill, a fascinating, yet ultimately too primitive subject for any meaningful dialogue. Perhaps they have evolved beyond biology entirely, becoming post-biological entities. You can imagine them having uploaded their consciousness into vast computational networks, existing now as beings of pure information. For such a civilization, the physical universe might lose its significance when compared to the infinite virtual worlds they could create, worlds where time can be manipulated and the laws of physics are whatever they choose them to be. Why would a society bother with the immense effort of interstellar travel when it can generate endless universes within its own computational matrix? It's possible that highly advanced civilizations invariably determine that cosmic expansion is an inefficient goal. They might opt for inward development instead, exploring the microcosm, the complexities of quantum dimensions, and the very structure of consciousness itself. There might even be a civilization somewhere that has mastered travel to parallel universes, for whom our entire reality is merely one among an infinite number of others. Or perhaps the most sophisticated beings have long ago abandoned the physical realm, now existing in other dimensions, within dark matter, the quantum foam of space-time, or in structures so alien we lack the capacity to even imagine them. If that's the case, it's hardly surprising we fail to see them. We scan the skies for radio signals, while they might communicate instantaneously through quantum entanglement. We look for colossal engineering projects, but they may have transitioned to technologies that leave no discernible footprint in the physical world. The truth may be that we simply haven't evolved sufficiently to recognize what a truly advanced civilization would look like, making our ideas of high technology as naive as a medieval person's concepts of a mission to Mars.
Alternatively, the zoo hypothesis could be in effect, the idea that a superior civilization is observing us, and has been since our species began. They might be waiting for us to reach a certain threshold of maturity before they make contact, much like a teacher waiting for a student to be prepared for a more advanced lesson. That moment could be approaching, revealing themselves only when we learn to coexist peacefully, stop endangering our planet, and seriously begin to explore the cosmos. For the time being, all we can do is speculate on the nature of these civilizations and the reasons for their apparent absence. Yet, the very act of asking these questions signifies that humanity is maturing, beginning to grasp its own position in the cosmic hierarchy of intelligence. But this raises a critical question. What happens if we actually detect a signal from an extraterrestrial civilization? Are we truly prepared for that reality? And who would be entrusted with the decision of how to respond? Picture the scene. A quiet evening at a radio observatory, perhaps somewhere in Chile. An astronomer is routinely analyzing the day's data, sipping coffee and thinking about heading home. Then, suddenly, a signal materializes on the screen. It's not background noise, nor is it interference from a satellite. It is a clear, artificial, modulated transmission from deep space. The astronomer's mug slips from their hand, but the spilled coffee goes unnoticed as they stare, mesmerized by the data, realizing this is the moment of first contact. What is the proper course of action in that situation? Do they phone their spouse to announce that we are not alone? Do they post on social media that human history has just been irrevocably altered? The answer is that they would strictly adhere to the protocol designed for this very contingency. These protocols, known as the post-detection protocols, were established in the 1980s when the search for extraterrestrial intelligence became a serious scientific endeavor, and they detail exactly what to do. The initial and most crucial step is confirmation. The astronomer who made the discovery is not permitted to make a unilateral announcement. They are required to contact their peers, tasking other telescopes to focus on the signal's source to ensure it is not a mistake, a technical glitch, or an elaborate hoax. Following this verification process comes notification. If the signal is authenticated, the data is formally transmitted to the Central Bureau for Astronomical Telegrams at Harvard, the institution responsible for officially chronicling all astronomical discoveries, which then distributes the alert to scientists across the globe. This is when the genuine trial starts, because establishing first contact with an alien civilization transcends a mere scientific breakthrough. It represents an event poised to reshape the entirety of human experience, from our politics and religions to our philosophies and economies. Consider the immediate response from global leaders, as presidents, prime ministers, and monarchs urgently call for emergency summits. What is our course of action? How do we proceed? Who possesses the authority to speak for all of humankind? This is when the genuine trial starts, because establishing first contact with an alien civilization transcends a mere scientific breakthrough. It represents an event poised to reshape the entirety of human experience, from our politics and religions to our philosophies and economies. Consider the immediate response from global leaders, as presidents, prime ministers, and monarchs urgently call for emergency summits. What is our course of action? How do we proceed? Who possesses the authority to speak for all of humankind? This is when the genuine trial starts, because establishing first contact with an alien civilization transcends a mere scientific breakthrough. It represents an event poised to reshape the entirety of human experience, from our politics and religions to our philosophies and economies. Consider the immediate response from global leaders, as presidents, Prime ministers and monarchs urgently call for emergency summits. What is our course of action? How do we proceed? Who possesses the authority to speak for all of humankind? Then you have the world's religious figures, who would face an immense challenge. How could they possibly convey to their followers that other intelligent life exists throughout the cosmos? How does this new reality reconcile with the long-held doctrine that humanity is the pinnacle of creation? While some faiths might adapt with relative ease, others could be fundamentally shaken, their core tenets thrown into question. Among the general public, reactions would be wildly diverse. You would see some celebrating what is arguably the most significant discovery in history, while others would descend into panic, gripped by the fear of an extraterrestrial invasion. A segment of the population would likely deny the evidence altogether, branding it as an elaborate government hoax. Just picture the ensuing digital chaos, a relentless flood of millions of posts, memes, conspiracy theories, and prophecies, making it nearly impossible to distinguish fact from fiction. On the first day, you might see stock markets plummet, only to skyrocket as the realization dawns that contact could usher in unimaginable technological advancements. However, the most profound questions will not be economic or political, but rather ethical. What do we do with the signal we have received? Should we transmit a reply, or should we maintain our silence? If we choose to answer, what message should we send? And who has the right to make that decision on behalf of every person on Earth? The existing protocols for such a scenario are frustratingly ambiguous, stating that any response must be decided upon by the international community without defining what that truly entails. Does it mean the United Nations Security Council or a global conference of all nations? What happens if countries disagree on the approach? Imagine a world where some nations seek to build friendly relations while others view the aliens as a potential menace, possibly triggering a new Cold War with an interstellar dimension. And the complications do not end there. What if the signal itself contains hazardous information, such as blueprints for superweapons, formulas for viruses capable of wiping out life on our planet, or even ideas so potent they could shatter human society? Some scientists advocate for not responding at all, arguing that we have no knowledge of the sender's identity or motives. They suggest it is far wiser to remain quiet and observe until we have a clearer understanding of who we are dealing with. Others strongly disagree with this cautious stance, positing that if we detected their signal, they likely already know of our existence, and our silence could be misinterpreted as hostility or a lack of intelligence. A third perspective proposes a carefully calculated middle path. Reply, but with extreme prudence. We could transmit universal constants like prime numbers and basic data about our planet, but without disclosing our location or the full extent of our technological prowess. Try to envision humanity's inaugural response. Perhaps something like, "Hello, we are humans from planet Earth, a carbon-based intelligent species. We come in peace." Alternatively, we could send something more intimate, like our music, poetry, and art, to demonstrate that we are not just intelligent, but also beings with culture, emotions, and aspirations. Another approach would be to begin with questions. Who are you? Where do you come from? Why did you reach out? To show our curiosity and readiness for a dialogue. But what if the extraterrestrials have been observing us for a very long time and are already intimately familiar with our species? In that scenario, they would not be looking for information in our reply, but rather for an indication of our maturity and readiness for contact. The nature of our response would then dictate their future posture toward us. In all of this, you know what concerns me the most? It is not the political or economic fallout. My deepest anxiety is how contact with an alien civilization will fundamentally alter us, our perception of our place in the universe, our search for the meaning of life, and our vision for humanity's future. The instant we receive confirmation that we are not alone, our identity will be irrevocably changed. We will become the junior members of a galactic family of intelligent species, a transformation that could be either the greatest blessing or the most formidable challenge in our entire history. For the time being, all we can do is prepare for that momentous day by advancing our technologies to better interpret signals from space and learning to collaborate as a unified species. More importantly, we must contemplate how we wish to introduce ourselves to our cosmic neighbors. To be truly ready for contact, however, we need instruments far more powerful than what we currently possess. Telescopes capable of seeing farther, listening more keenly, and analyzing more deeply. And those tools are already being designed. Let's now peer into the future of the search for extraterrestrial intelligence. Picture a telescope with an aperture the size of an entire planet. This may sound like something from science fiction, but such instruments could become a reality within the next few decades. In the 2030s, in the Atacama Desert of Chile, the driest location on Earth, an array of 10,000 radio telescopes is under construction. While each dish is only about the size of a car, they will operate in unison as a single colossal instrument, the Square Kilometer Array, or SKA. This will be the most powerful radio telescope ever built, boasting a sensitivity 100 times greater than any existing telescope, enabling it to detect a signal from a mobile phone located several light years away. It will simultaneously listen to 1 million stars across billions of frequency channels. Imagine the sheer quantity of data this array will produce. Exabytes of information every single second, surpassing the output of the entire internet. Only the next generation of artificial intelligence will be capable of processing such a massive data stream. Meanwhile, in orbit, new kinds of space telescopes will be deployed. These will not be single massive instruments, but rather swarms of 100 smaller telescopes functioning as a single cohesive system to produce images with a resolution far beyond what Earth-based observatories can achieve. A telescope of this design will not simply detect exoplanets. It will meticulously study their atmospheres, searching for traces of water vapor, oxygen, and methane, gases that could signify life, or even the industrial pollution of an advanced civilization. Consider the possibility of finding chlorofluorocarbons, which are entirely artificial gases, in the atmosphere of a world far from our own. Such a discovery would stand as the first unambiguous proof of a technological society, revealed not through signals or immense constructions, but through the chemical byproducts of its industry. This is where quantum technologies will introduce a whole new realm of possibilities, allowing quantum computers to analyze cosmic signals in ways we can't currently achieve. Quantum communication might even offer instantaneous data transfer across any distance, raising the prospect that advanced cultures are already using it, and we are simply deaf to their conversations because we lack the right tools. With the development of quantum detectors, however, we could begin to tune into these previously hidden channels. But what if the next great breakthrough comes not from a human astronomer, but from an artificial intelligence? An AI could sift through vast data sets and identify patterns that a human mind would completely overlook, potentially uncovering signals cleverly camouflaged as natural cosmic noise. It's a humorous thought, isn't it? That our robotic explorers might be the ones to find other robots, or the beings who built them. Then you have the concept of interstellar probes, with projects already in development to dispatch robotic emissaries to nearby star systems. These would be minuscule craft, propelled by powerful laser beams to a significant fraction of the speed of light. The Breakthrough Starshot Initiative, for example, plans to launch thousands of these nanoprobes toward Proxima Centauri. Each device, though no larger than a postage stamp, will be outfitted with cameras, sensors, and a transmitter, designed to make the journey in just 20 years and return the very first pictures of an exoplanet. Picture that incredible moment sometime in the 2060s when Earth finally receives a transmission from a probe orbiting a planet near Proxima Centauri. Contained within that signal are not just specks of light viewed through a telescope, but actual, detailed images of another world. And perhaps these photos will reveal something extraordinary. Cityscapes, engineered structures, the clear signature of a civilization. Or they might show a barren, lifeless world, offering stark evidence of how precious and rare life truly is in the cosmos. Even if a signal from an extraterrestrial civilization proved to be utterly alien, artificial intelligence could be our key to understanding it. AI possesses the potential to discern patterns in any form of data, break any code, and translate any conceivable language. Imagine capturing a complex alien transmission, feeding it into a quantum computer powered by AI, and hours later, receiving a clear translation. Hello, neighbors. We are so glad you finally reached out. Perhaps the whole future of this search has less to do with telescopes and signals than we think. It's possible we will only encounter our intelligent counterparts once we begin our own active expansion into space, establishing outposts on Mars, settling the asteroid belt, and building cities on the moons of giant planets. Or maybe life is so abundant that we will discover it nearly everywhere we look, beneath the ice of Europa, within the geysers of Enceladus, on the shores of Titan's methane lakes, or even floating in the acidic clouds of Venus. At that point, the question would shift from, "Are we alone?" to, "Why did we ever believe we were?" But what if the most profound discovery is not waiting for us in space, but is already here on Earth? Imagine finding traces of alien life embedded within ancient rock formations, or learning that certain terrestrial organisms actually have an extraterrestrial ancestry. It's a staggering thought, that while we scan distant star systems, life from beyond Earth has been with us all along, with some cave-dwelling bacteria or deep-sea viruses being the direct descendants of organisms that arrived here billions of years ago. This idea leads to an even deeper question. What if humanity itself is partly of extraterrestrial descent? If the seeds of life were delivered to our world by comets and asteroids, then our search for life elsewhere is simultaneously a quest to uncover our own cosmic origins. Ultimately, though, no matter how advanced our technology becomes, the most critical element in the search for extraterrestrial intelligence is not the equipment, but the people driving it. It's about the scientists who commit their entire careers to this question, and the engineers who build the incredible instruments for the task. It's also about the countless ordinary individuals who contribute by helping to analyze the data. And most importantly, it's about the children dreaming of the stars today, because one of them may grow up to be the first person to hear a voice from space, or to walk on a world teeming with alien life. When that day arrives, you will see that our quest was never just a scientific endeavor. It has always been humanity's grand journey to comprehend its own place in the universe, a process that has profoundly changed us, even without a definitive discovery. In fact, maybe we have already found what we were looking for. Through the search for cosmic neighbors, we have started to better understand ourselves, becoming a more cohesive species and a civilization better prepared for a dialogue with another intelligence. Perhaps that is precisely what other advanced beings in the galaxy are waiting for. They might not be waiting for us to simply detect their signal, but for us to become mature enough to join the galactic community. For now, the search goes on. Every day, every night, every single second. And the answer to our species' most fundamental question could be waiting for us as soon as tomorrow. We have now traveled to the conceptual edges of the universe in our search for intelligent life, which brings us to the ultimate question. Are we alone? To be honest, I don't have the answer. Nobody does. But the remarkable thing is, the answer itself may not be the most important part. The very act of searching for it has already transformed us in ways we are only beginning to grasp. Think about the progress we've made. A century ago, you would have looked up at the night sky and seen only points of light. Today, we understand that each of those stars is a sun, many with their own families of planets. We have learned that our universe contains trillions of galaxies, each holding billions of stars, and have identified countless exoplanets, a great number of which could support life. From finding water on Mars to discovering subsurface oceans on the moons of Jupiter and Saturn, we have come an incredibly long way, and the search continues as we discover that life can thrive in the most extreme conditions imaginable. Above all else, we have come to the realization that the cosmos is immeasurably larger, more varied, and more magnificent than our ancestors could have ever conceived. Within this vast and miracle-laden universe, we have discovered our true context. We no longer see ourselves as the pinnacle of creation. Instead, we understand that we inhabit just one planet, orbiting one of countless stars, within one of billions of galaxies. This perspective, however, doesn't diminish our importance. On the contrary, it confirms that we are an interwoven part of something unbelievably immense and beautiful. The quest for extraterrestrial life has given us a profound new appreciation for our own world. As you search for biological signatures on other planets, you develop a much deeper grasp of just how miraculous Earth truly is, and you recognize the incredible sequence of events that had to align perfectly for life to emerge here. This might just be the most vital lesson learned from our entire endeavor. Whether life exists elsewhere or not, our planet is singularly precious, and as the only home we have, it is our duty to cherish it. This cosmic search has also served as a powerful unifying force for our species. When we turn our instruments to the stars, we are not acting as Americans, Russians, or Chinese, but as a collective humanity, as ambassadors of Earth's civilization. Should we ever detect a signal from another world, our reply will not come from a single nation or culture. It will be a message sent on behalf of every person on this planet, which is an exceptionally beautiful thought. Imagine for a moment that aliens land on Earth and pose the question, who is in charge here? Our response would be that we don't have a single leader. We would explain that we are a diverse people, but fundamentally we are all human. Together, we represent our entire planet. In this way, the search for extraterrestrial life transcends science and becomes a philosophical journey, prompting us to examine what it truly means to be alive, to possess intelligence, and to be human. As we attempt to envision what extraterrestrial beings might be like, we invariably gain a clearer understanding of life on Earth. When you contemplate the nature of alien intelligence, you find yourself with a more profound insight into human consciousness. So, perhaps the most critical aspect of looking for extraterrestrial life isn't actually finding it, but rather the process of becoming a civilization that is worthy of that discovery. This involves evolving into a species prepared for contact with other intelligent beings.
This means learning to coexist peacefully, eradicating the scourges of war, hunger, and ecological ruin, and becoming a species that no longer poses a threat to its own planet or to itself. It's possible this is precisely what our cosmic neighbors are waiting for. Maybe they are observing us from afar, thinking, they are an interesting species but far too volatile. We will wait for them to mature. If that's the reality, then the search for alien life is more than a scientific project. It's a moral imperative, a catalyst for us to become better, wiser, and kinder, ultimately earning our place in the galactic community. But what if we are genuinely by ourselves? What if, across the entire expanse of the observable universe, we represent the only form of intelligent life? That outcome would certainly be tinged with sadness, but it would also be incredibly significant. It would mean that we are the universe's sole bearers of consciousness, the only ones capable of appreciating the beauty of the stars, understanding the complexities of physics, and exploring the depths of mathematics. We would be the only beings who can create art, compose music, and write poetry. If that were true, our responsibility would become even more immense. Our purpose would extend beyond mere survival. It would compel us to spread life and reason throughout the cosmos. We would have to become the ones who settle empty worlds, who foster new civilizations, and who carry the flame of consciousness into the cosmic darkness. I, however, am convinced that we are not alone. The universe is simply too vast, the number of planets too great, and life itself is too tenacious and inventive for that to be the case. Somewhere out there, scattered among trillions of stars, other worlds must exist, with other beings who also gaze at their skies and ponder the very same questions we do. It's entirely possible that they are also searching for us. Perhaps at this very moment, in a galaxy far away, another civilization is aiming its telescopes in our direction, listening intently for radio waves from Earth. Or could it be that they have already found us? Maybe our own radio and television signals, which we've been broadcasting into space for more than a century, have already reached them. They might be analyzing our transmissions right now, thinking, this is a fascinating civilization. Perhaps it's time to make contact. Imagine this scenario. Somewhere in the Ursa Major constellation, a group of aliens is watching our television shows from 70 years ago, concluding, these humans are peculiar creatures, but they have this thing they call music. That is quite interesting. It's also possible that first contact won't occur through radio signals at all, but through a physical meeting in space. As we begin to more actively explore other planets in our own system, we might encounter someone who has journeyed from another world. Or maybe we will discover traces of their past activities, ancient artifacts left on the moon, unusual structures within the asteroid belt, or strange signals emanating from distant moons. It's even conceivable they are already here, but we simply fail to perceive them, existing on scales of time and space that render them invisible to us, much like bacteria are oblivious to the humans walking above them. But here is the critical point. Regardless of when or how first contact happens, it will irreversibly transform us. We will finally understand that we are not unique, and that intelligence is a widespread phenomenon in the universe. This revelation will be both humbling and inspiring. It will be humbling because we will have to accept that we are not special, that civilizations far older and wiser than our own exist, and that we are essentially children in a vast galactic family. Yet, it will also be profoundly inspiring, because we will see that we have a future, that we can learn and grow, and that incredible discoveries and adventures lie ahead. Until that day comes, we will continue the search.
We will construct new telescopes, innovate new technologies, and venture to new worlds. With each passing day, we move closer to resolving the ultimate question. Are we alone? And you know, the answer might just change not only our conception of the universe, but also our fundamental understanding of ourselves. It may be that in our search for intelligent neighbors, we will stumble upon something even more valuable. We will find ourselves. Ultimately, whether we are solitary in this universe is not the central issue. What holds true significance is our relentless search, our capacity to dream, and our drive to do more than simply exist by questioning the very meaning of our presence here. In fact, this impulse might be the genuine hallmark of intelligence. Not our skill in fabricating tools or constructing cities, but our ability to gaze into the cosmos and ask, is anyone else out there? We are destined to uncover the answer to this question. It might happen tomorrow, in the next year, or even a century from now. But the discovery is inevitable. When that day comes, we will recognize that the entire endeavor was profoundly worthwhile. The quest for intelligent neighbors has taught us to better understand one another, forging us into a more unified species and leaving us better prepared for whatever the future may bring. This may be the most crucial lesson of our journey. We are not truly alone, even if we are biologically unique. We have each other, we have our homeworld, and we possess our collective dreams of the stars. This is already a tremendous amount, and it makes us exceptional within the universe, regardless of who or what else might exist. The very capacity for this search sets us apart. So, the next time you find yourself looking up at the star-filled sky, hold this thought. Somewhere in that vastness, another being might be staring back, dreaming of the day we might meet. And even if no one is there, the fact that you can ponder this possibility is what makes the universe such a magnificent place. Our exploration goes on, and you could be the one who receives that first signal from an alien intelligence. If not you, perhaps it will be your children or your grandchildren, but a human will hear it, and in that instant, we will finally grasp that we are not isolated. We will understand that the universe has room for all, that consciousness is a gift to be cultivated, and that our future is inextricably linked not just to Earth, but to the stars themselves.